Assalamualaikum. Hello. Here we are again to discuss subtopic 1.4 and 1.5 of Introduction to Organic Chemistry. What is hydrocarbon? Hydrocarbon is an organic compound made of only hydrogen and carbon. Hydrocarbons are obtained from the fractional distillation process of crude oil. We use them for fuels in cars and in cookers. Several characteristics of hydrocarbon. Hydrocarbon is insoluble in water. It is a non-polar molecule. Hydrocarbon burn in air to produce carbon dioxide and water. And hydrocarbon has low intermolecular forces. Classes of hydrocarbon. Hydrocarbon can be classified into two classes, aliphatic and aromatic. Aliphatic is the hydrocarbon that have carbon atom arranged in straight or branch chain or as ring structures. Also classified as, we can say that aliphatic hydrocarbon is an open chain structure. Aromatic hydrocarbons is the hydrocarbons that contain a benzene ring, and aliphatic hydrocarbons do not contain benzene ring structures. Aliphatic hydrocarbons can further be classified into alkanes, alkenes, and alkynes. Alkanes are hydrocarbons in which all of the bonds are single bonds, while alkenes are hydrocarbons that contain a carbon-carbon double bond. Meanwhile, alkynes are hydrocarbons that contain a carbon-carbon triple bond. For aromatic hydrocarbon, it is easy for you to identify. It is because the characteristic of aromatic hydrocarbon, it must contain a benzene ring. The most common aromatic hydrocarbons are those that contain at least a benzene ring. Now let's look into saturated and unsaturated hydrocarbon. Saturated hydrocarbon is when the hydrocarbon has maximum number of hydrogen atoms attached to each carbon atoms. And in saturated hydrocarbons, it only contains a single carbon-carbon bond. Examples are alkane and cycloalkanes. Basically, the relativity of saturated hydrocarbon are low. And for unsaturated, the molecule that are unsaturated hydrocarbon has fewer hydrogen atoms attached to the carbon chain than alkanes. It is because they contains multiple bonds, either double bond or carbon-carbon triple bonds. Examples for unsaturated hydrocarbons are alkenes with double bonds, and alkynes with triple bonds, and aromatic hydrocarbons. This unsaturated hydrocarbon is more reactive than their saturated counterpart. These are the examples of saturated hydrocarbons: ethane, cyclopropane, butane, cyclopentane. As you can see, all the structures given only contain carbon single bond. And here is the examples of unsaturated hydrocarbons. We have propene, ethane, pentene, and cyclohexane. And for this unsaturated hydrocarbon, as you can see, it can be cyclic or open chain. With the requirement, it must have the carbon-carbon double bond or carbon-carbon triple bond. Now, let's look into 1.5 isomerism. Isomerism is the existence of different compounds with the same molecular formula but different structural formula. Compounds that have the same molecular formula but different structural formula are called isomers. Isomers can be classified into constitutional isomers. The other name for constitutional isomers is structural isomers. These structural isomers can be classified into three: chain isomers, functional group isomers, and positional isomers. Let's check for the first isomers, which is chain isomer. Chain isomer differ in the carbon skeleton, which means the carbon chain is different, possess the same functional group, and belong to the same homologous series. So these isomers basically have similar chemical properties, slightly different physical properties, where more branching will have lower boiling point. So for example, for hydrocarbon C5H12 pentane, pentane can have three isomers. For chain isomers of pentane, we can have straight chain isomers, where all the 5 carbons are arranged in a line, or we can have a branch structural isomers, where for this one branch isomers, the 4 carbon is the parent carbon and one CH3 group becomes the branch. And the third isomer for pentane is 2,2-dimethyl propane, and as you can see, the parent chain carbon is 3 and it has 2 branch that is known as methyl groups. Second isomer is positional isomerism. Positional isomerisms differ in the different position of functional groups. The isomer have same functional group but only differ in the position. Same carbon skeleton, same functional group, and similar chemical properties and slightly different in physical properties. To make you understand about the positional isomerisms, so this is the example. Okay, as you can see, this is the haloalkane where the chlorine atoms is the functional group here. For the first isomer, the chlorine is situated at the first carbon. And for the second isomer, the chlorine atoms is situated at carbon number 2. The parent chain is still 3, but the position of chlorine is different. The second example is butene. Okay, as you can see here, the carbon-carbon double bond is the functional group for butene, and for the first isomer, the carbon-carbon double bond is between carbon number 1 and carbon number 2. And for the second isomer, the carbon-carbon double bond is situated at carbon number 2 and carbon number 3. This is what we call positional isomerism. Same skeletal structure, but differ in the position of functional groups. The third one is the functional group isomerism. So functional group isomerism, different functional group and homologous series, different chemical properties, different physical properties. So functional group isomerism has all the differences in terms of physical, chemical, and also their functional group and homologous series. But one thing in similar is the same general formula. There are 4 pairs of functional group isomers. The first pair is aldehyde and ketones. They share the same general formula CnH2NO, alcohol and ether, carboxylic acid and ester, and the last pair is alkene and cycloalkane. Here are the examples to show you the pairs of functional group isomerism. For the first pair is alcohol and ether. So as you can see, both have the general formula of C2H6O. Both alcohol and ether have 2 carbon, 6 hydrogen, and 1 oxygen atom. The difference is how the atoms are arranged and the functional groups. Second pair is the aldehyde and ketone. Both have general formula of C3H6O, but only differ in the functional group. As you can see, the functional group of aldehyde is C double bond OH, and functional group of ketone is C double bond O attached to 2 carbon. Third pair to show the functional group isomerism is carboxylic acid and ester. Both have same general formula C3H6O2. As you can see, this is the functional group of carboxylic acid, carboxyl, and this is the functional group of ester, carboalkoxy. Same general formula, but different functional groups. And last pair to show the functional group isomerism, here is C4H8. With the general formula of C4H8, we can have alkene and cycloalkane. So this is the structure of alkane with 4 carbon in cyclic structure, and this is the alkene with 4 carbon. So sometimes more than one type of isomerism occurs in the same molecules. So the more carbon atoms there are, the greater the number of possible isomers. So that's all for isomerism and hydrocarbon. See you again. Bye.